So now hopefully you can see my screen. Okay, you start recording, that is fine, but you keep pay attention. So chapter 1 we completed. Okay, that was an important chapter, and then we'll go to the chapter 2, um, which is performance characteristics of instrument. Okay, in Doeblin it might be chapter 3 or something else. This is also very important chapter, and it is not related to any specific instrument, but in general it is related to all the instrument, and this you should know very carefully before you try to apply or try to implement any equipment or instrument for measuring some parameters. So what this chapter says or what you need to know, let me give some brief introduction, then I will come. So suppose you want to measure some parameter, physical parameters, and for some experiment or for some engineering system design or something else. So now the physical parameter can be many things. It can be temperature, pressure, it can be radiation, it can be many things. Okay, good. So your objective is to measure that. Now the two things could happen. Now the thing is that you have many choice in your hand. That means you may have many type of instrument. Even for a single type of instrument, you may have many instrument with different ratings. Now the point is, what do you choose among them and why? That is the most important question you need to understand before you buy something or to measure or to design an engineering system. So what I am saying, try to understand very carefully. I am trying to say that you want to measure some physical parameters or many physical parameters. For that, you have a set of instruments. Okay, suppose you want to measure temperature and you have a different type of thermometers. Among them, let's say you choose the mercury thermometer, and then you might have the mercury thermometer from different makers which has the different characteristics. Which one you will pick? That is the most prominent question. Which one you will pick and why? So this question you have to answer. Arbitrarily, you cannot take any instrument and plug in. Everywhere you have to answer why you choose that instrument. So it based on some characteristics. So you have to know various characteristics. How do you know it? Either you know it from the manuals or you know it by doing experiments. This is one thing. Second thing is that how much money you can spend, because if you go very accurate, very high-fi instrument, your amount of your budget will be more. So these two things are there. So based on that, so you need to know with how much accuracy, with how much precision, with how much different parameter you want to measure, and you need to measure. And if you know that, and then it will be easy to choose a particular instrument for a particular application based on your need and based on your specification of the instrument. So you need to know what are the different characteristics you need to study, or what are the different specification your instrument must have, so that you can choose that for your specific application. So this is the philosophy. Okay. So is it okay, or you want to ask some question? Let me see. Oh, um, Modhu Join says that can you please share this slide? Okay, share this slide means not the desktop sharing, just mailing, that you mean to say, right? No problem, I will mail it today. There is absolutely no issue. Okay. So so now tell me if this philosophy you understand, or you, let me tell again. Suppose you want to choose a particular type of instrument for a particular application. So you need to know what are the different parameters, different characteristics you need to see before any choice. So those characteristics are known as the performance characteristics, and those performance characteristics you need to see from the manual, and you need to know that which is good and which is bad and which is not so good, and what is your requirement, what is your budget. Based on all those things, you can select a particular instrument. Okay. So if that is clear, second thing I want to emphasize, whenever you are going to select some instrument for a measurement, for measuring some measurement, you need to think two ways. First thing is that whether your input is static, that means it is not changing with time, or it is changing with time very, very slowly, that we call a static input. So whether your input is static or your input is dynamic, that means whether your input is changing very rapidly or quite rapidly with time. So what you want to measure, either static input or dynamic input, that is the first thing. If you want to measure a static input, for example, temperature of a human body, it is a kind of static input if you want to measure it. Now, if you want to measure a dynamic input, that means changing of uh, current or voltage, power line voltage, that is a dynamic input because it is changing over time very frequently. Now, first you have to concentrate whether you want to measure the static input or you want to measure the dynamic input. What is your objective? Many times measuring the static input is quite it's the requirement, because if you see the temperature of ambient temperature, if you see the strain, these are quite static input. Either they don't change with time or they change with time very slowly. So if you want to measure static input, you need to consider few performance characteristics. Based on that, you can choose your measurement system. If you want to dynamic input, what is the meaning of dynamic input? When the input is changing with time quite rapidly or considerably, then you have to consider separate type of performance characteristics. So first thing is that what is your input, whether it is static or dynamic. So let's focus on the static input. Suppose you have a static input, then you must study the different performance characteristics of the instrument, and you have to note down all the performance characteristics, and then you need to see that among various instrument or various makers or various type of instrument, which is good or which is bad, and which is sufficient for your purpose. Based on that, you can select a measuring instrument, and that instrument you can choose for your specific engineering design. Okay, so is that clear to all of you? You can ask question, or if it is clear, you can say it is fine or okay. So that also good. It also. So now do you understand what is the philosophy behind the studying performance characteristics of any instrument? It is very important. So most of the cases when we are we go for a Viva, BTP, BTech project or design lab something, student just plug in some measuring instrument, and then when we ask why you choose that, so is it sufficient or it is more than sufficient? What are the characteristics you study? They could not answer. Okay, that means it's not in engineering choice, it is an arbitrary choice. So it should not be arbitrary choice. Okay, so now nobody responded anything, so I don't know, so maybe you understood. So let me proceed to the next. So now, to start with, what we will consider? We will consider a static input. That means the input is not changing with time, or if input is changing with time, it is changing with time very drastically. Okay, so the instrument performance characteristics is generally, you can divide into two parts. First thing is the static characteristic, next thing is the dynamic characteristics. Now there may be some cases where you don't know whether the input will be static or dynamic, or it could be mixed. For some part of the time it is static, and for some part of the time it is dynamic. Then both of the things you need to study. Now let's come to static characteristics. What is the static characteristics? Static characteristics describe the performance of an instrument under constant input or very slowly varying input. Okay, so what does it mean? Suppose you want to measure something, it may vary the input, or after the varying the input, it may settle somewhere, and that steady state you want to measure. It's quite okay, and many of the cases we do so. So we concerned with the steady state reading means that when the transient dies out and the instrument settle down to a value, then if we want to measure that steady state unit, that is obviously a static input. Okay. since the static characteristics affect the dynamic behavior, the overall performance is can be judged by the superposition of static and dynamic characteristics. That is always obvious. So dynamic characteristics of the instrument is also important to know, even if you are giving the static input, because if you give the static input, the output of the instrument will not go to immediately settle some point. It will output of the instrument will go to the some transient and then will settle in the time, settle after time. So we need to know how much time we should wait before taking the readings when we are giving a static input to any measuring instrument. So there are many terminologies, there are many parameters through which you can describe or you need to know for the performance characteristics due to static input. For example, range, span, linearity, threshold, resolution, error, etc., many things. One thing before going into detail, I will ask you to note that there are many terms which seems very similar, but they are not in engineering sense. So you must emphasize that the terms are not similar, but they seem similar if you see the dictionary or something. But in engineering sense, they are slightly different. You need to know all those things. Let's proceed. Okay. So let me see if anybody asks anything. No, there is no. So let me proceed now. So the first thing I should discuss is the range and the span. Whenever we have an instrument, we always want to see what is its range, what is its span. What the mean of the range? Range means the limit between which the input can vary. That means, so suppose you have a mercury thermometer. It's not maybe not the clinical thermometer. It might be some uh, simple ordinary room temperature, ambient, whatever you measure. So suppose its lower point is 0, higher point is 100 degrees centigrade. So whenever you see some instrument, you always need to know what is the range. That means within what value your instrument can measure. So that means you need to describe the range by means of minimum and the maximum. So if I give you a temperature thermometer, I say, tell me what is the range. You need to say its range is 0 degree centigrade to 100 degree centigrade. So range of an instrument defines the minimum and maximum values of the quantity that instrument is designated to measure. Now, if I give a pressure gauge, you see that always that in very ordinary examples, you can see that the car tire pressure, bike tire pressure, always there is a pressure gauge we used to give air inside the tire of the or tube of the bike or car. So they put some air and they used to check the pressure. So if I say that what is the input and output, what is the range of that? Maybe it is 0 atmospheric pressure to 50 atmospheric pressure or 100 atmospheric pressure. So knowing range is very important for any instrument. Why? Because if you know the range of an instrument, then only you can see whether this instrument is perfectly useful to your application or not. Suppose you want to measure the 200 volts and you are using an instrument which is range is 0 to 5 volts. Is it possible to measure? No. So this is not useful in your particular case. And now suppose you want to measure 0 to 5 volt and you have an instrument which range is 0 to 200 volt. Can you use it? Obviously you can use it, but your measurement will not be so accurate because your full scale reading will be 5 volt and then that will cover a very small range of your instrument. So it is not also not useful, or it is not good to use such instrument in your application. So this thing you need to be very careful, that what maybe you don't know your measurement, you don't know what the value of it, but you know the range what you are going to measure, and your instrument should be inside that range and well inside the range, should not be below the range, should not be too above the range, so that you will not get the good measure. So range is very important. Whenever this is the first thing you should consider. Whenever you are thinking some instrument, you need to see that what will be your measurement, what may be the tentative minimum and maximum values, and based on that you select some instrument whose range is in between that. It's not to over range or not to lower range. So whenever I ask, tell me the range, you have to tell the lower limit and the upper limit. For example, 0 degree centigrade to 100 degree centigrade. 0 atmospheric pressure to 100 atmospheric pressure, like that you have to take. Or if you are using platinum resistance thermometer or something else, you have to tell this minus this degree centigrade to minus plus that degree centigrade. So these things are very important, and whenever you see some manual of any instrument, you first thing you need to see the range, and you need to see whether this range is useful for your application, and whether this the input you are going to give is lies between this range. Okay, fine. Now let's tell me the span. What is the span? Range and span, they are quite synonymous, but here there is some difference. The span is the maximum variation. That means, so if you see what is the span of an instrument, so output whatever you will get, or whatever the input range it can measure, that is maximum minus minimum. So if I said, if I a temperature thermometer which can measure a 0 degree centigrade to 100 degree centigrade, what will be its span? Its span will be 100 minus 0 will be that means equals to 100. Suppose you have a temperature which can measure minus 100 degree centigrade to plus 200 degree centigrade, then I can say, if I ask what is its span, so it will be to minus 100 to plus 200, that means 300 degree centigrade is its span. So, but the range, whenever I ask what is the range, you have to say the lower limit, you have to say the upper limit. Whenever I say the span, you have to divide the upper limit, you have to subtract the upper limit and lower limit, and you have to tell the span. So these are the two different things. And before using any instrument, it is very important to know the range and span. And by that things, you will see that whether this instrument is fitting in your application or not. Next thing. So let me see if there any query. Okay, very good. Everybody is understanding. So it's very nice. Let's move to the next part. So another thing is that linearity. What is the meaning of the linearity? So an instrument could be linear, an instrument could be non-linear. Okay. So the output reading of an instrument is linearly proportional to the quantity being measured. That means you have, if you plot the input output, it will lie on a line. Okay, so input output relationship is governed by a straight line. Input output relationship is governed by a straight line. Then you got it is a linearity. So the next thing you need to know whether your instrument is linear or not, and it is a very, very important characteristics. If you get any linear instrument, you must choose it, because linearity is a simple relationship. If you need to know the measurement quantity, just you take the output, multiply it with something, and always multiply with that, and you will get that is the slope, and you will get the output. So linearity is a very, very very, very useful properties or characteristics of an instrument. Sometimes it may happen that your instrument, after you design your instrument, it is no longer linear, and many times it happens so it is no longer linear. So if the instrument is no longer linear, then what you could do? Okay, they did not say. Okay, if your instrument is no longer linear, then you are in a trouble, because for all the range you don't have the constant value for multiplication. It is some curve. So input output relationship is not linear. There is no slope. So what you can do in such cases? Because in such cases the measuring device or the measurement becomes complicated. So what you need to do, there are a few things you need to do. First thing you can do, you linearize. Suppose you have a non-linear relationship, you linearize it, okay, using Taylor series expansion or something else. Then if you linearize such thing, so you will get a linearized expression, you will get a linearized relationship. True relationship is non-linear, but you will get a linearized relationship. That's your job is done. But wait, there is some warning. If you linearize a non-linear relationship, there is errors, and sometimes the error is huge. And if you don't do anything else, this huge error will lead to a wrong measurement of your measuring. Okay, that you have to be very careful. Generally, people used to do linearization and think about the system is linear. It's not. You can linearize it, fine. You can use it, fine. But always you need to see that how much error is incorporated or coming inside due to linearization process, and that error should not be very high. This is one approach. If you have a non-linear instrument, you can linearize it. Second approach is, okay, nowadays, earlier days, there was no microcontroller, there was no computer associated with any sensor. Nowadays, almost every sensor has a computer or microcontroller associated with it, because nowadays the microcontroller or even the computing device inbuilt with the instrument, it is becoming very cheap. So what you can do, you can exactly give the nonlinear relation inside the computer or microcomputer of the instrument. So whatever input you give, you take that input and give it to fit it to nonlinear equation, and then output you will get. Do it reverse. Whatever output you get, you fit it to that nonlinear relationship, you will get the input and you display the input. That is a very good approach. You can do it. Third point, you can do a lookup table approach. What is that? So you make a lookup table. That means if this is the output, what will be the input? If this is the output, what will be the input? And fit this lookup table inside the computer of an instrument. So whatever output you get, instrument go to its memory, see the lookup table, and it returns the corresponding measurand value as the measurand values. So that's it, it's done. So the main takeaway is the linearity is a very important concept or important characteristics of any measuring device, and we always look for a linear instrument. Whenever you get a linear instrument, that is best, but many times it is not possible to get linear instrument. While constructing the instrument becomes non-linear, then we need to deal with the non-linear instrument. How we deal with the non-linear instrument? We can deal with the non-linear instrument by point one, linearize it by using Taylor series expansion or some other means. And then you have to be very cautious. If you linearize, always you will get a linearized expression. But wait, that there is a error, linearization error associated with it, and that might be very high for some values. So you have to be very careful. Second point, you can feed, as the instruments are nowadays smart, they have their processing unit, they have the memory. You can feed the exact nonlinear equation into the memory and then get the output. You feed it to the nonlinear equation, you will get the input, and then you display that measurement value. That is another approach. Next approach is a lookup table. You make a lookup table. If that is the output, what is the measurement value? If that is the output, what is the measurement value? And feed this lookup table inside the computer or inside the processor of the instrument. And then whenever you get some output, you look at the lookup table, or the instrument will look at the lookup table, and then it returns the values of the measurement. That way you could deal with the nonlinear systems. Okay, that's all about the nonlinearity or linearity. Now tell me if you have any query. No query still? Oh, it's surprising. So am I audible, right? I'm not speaking blankly. Okay, let's move to the next point. Now, the sensitivity, it is also another very important concept. What is the sensitivity? Suppose you have a measuring instrument, you have some input, you get some output, right? So, and you have some small change of input, you get the small change of output. Now, the ratio of the change in output to the change in input under steady state condition is called the sensitivity. What does it mean? Suppose you have input Qi, you have output Q0, and you change the input little by delta Qi, and your output will definitely change. Let's say delta Q0. Then your sensitivity will be the ratio of delta Q0 by delta Qi. That will be nothing but your sensitivity. So, if that is the sensitivity, that means if some change happens in input, how much change will happen to output? That is called the sensitivity. If some change happens in input, how much change will happen to output? Now let's come to our. This is for a linear system. I will come to non-linear thing. Don't worry. But before that, you need to understand what is the physical meaning or physical sense carrying by the sensitivity. Suppose you have an instrument. Okay, let's say thermometer, simplest instrument, and input 1 degree change happen. One thermometer gives the output for 1 degree change in input as 1 millimeter. Another thermometers also, let's see, 1 degree change in input happens, gives the output say 10 millimeter. So which one is more sensitive? the thermometer which gives the output 10 millimeter for a change in 1 degree input is the more sensitive, right? And which one will be useful or which one will be more acceptable? You should choose it. Suppose you got the two instrument, one sensitivity is high, another sensitivity is low. Which instrument you will choose? You will choose the high sensitive instrument, because for small change in input, if you get the large change in output, that means you can measure it. If you see the 1 millimeter change, you can mark it maybe in one unit or 2 unit, so that you can only measure the temperature change of 0.5 degree. And if you get the 10 millimeter output, you can mark it as a 10 with the 10 scale. So you can get the change, you can measure 0.1 degree centigrade of the input. That means your sensitivity is high. You can measure more sensitive way. So this is the sensitivity. So whenever you look for an instrument, if an instrument is more sensitive, that is acceptable, that you can choose it. Because for the small change in input, you can get the large change in output. Okay, that is what sensitivity called. Now sometimes it happens that the input output relationship is not linear. If the input output relationship is not linear, then you see the figure B, it may be the curve, so indicates how much output changes. So what we do generally on that point, that is called the nominal point, you take a tangent, and through that tangent means you just linearize that point. In that you make a triangle, and then you see that how much Q0 is changing and how much Qi, and then you do the ratio of that. Okay, so sensitivity can be for linear instrument, it can be for nonlinear instrument, but main thing is that sensitivity means that how much output change happens for the same change in input or unit change in input. So that is the ratio between the output and input change, and that is called the sensitivity. A sensitivity, high sensitivity is good for any application, because in that case you can measure the input more accurately, or more finer way, I must say, more finer way. So that is what the sensitivity is very important, and you need to look at the sensitivity of any instrument before you use it. And if you see that the same sensitivity is high, you should choose that instrument. Now tell me if you have any query. Nothing. Nobody is saying anything. Okay. Okay. Utkarsh is saying, does increasing the sensitivity increases the error? No, it is not. Increasing the sensitivity will not change the error, will not increase the error, because if it is a, let's say, linear instrument, so if some change happens and you do the mechanism such that more output displacement you get, so it does not increases the error definitely, but it may have a little adverse effect in different way. For example, I am telling a very simple example. Suppose you have a mercury thermometer, and one mercury thermometer is more sensitive to another. I am saying that 1 degree change in input, one mercury get displaced in 1 millimeter, and for same change in input, one mercury get displaced 10 millimeter. So the thermometer which is giving you displacement of 10 millimeter must have more mercury inside the thermometer, because it need to travel for the same range, because it need to travel long distance, so the mercury should expand, so the bulb must have more mercury, so that it will come through the capillary and go and expanding, and the thermometer will be more lengthy for the same range, you mind it, same range. Now the point is, suppose if you have more mercury inside the bulb, so to expand it, it will take more heat. So if it takes more heat, then what will happen? Then the temperature of the measurement can come down, go down, which is not desirable. Our main philosophy is we must measure it without affecting the measurement to change its value. So that is one disadvantage. So the sensitivity, for increasing sensitivity, we need to increase the bulb value, bulb volume, and bulb volume means mercury will increase quantity, it will take more heat, and the measurement and the medium temperature will go down. That is not desirable. That is one part. Next part, I said that it become more bulky if you give a straight line, more elongation or more thing. So this thing may happen, but error will not be more definitely. It may have some adverse effect too, but you need to balance it. See that how much adverse effect is there and how much advantage you are getting. Okay, error will not be high. Fine, I guess Utkarsh, you get your answer. But noise will also be faded as the input in some cases. Noise we are not considering. Whenever we will consider, the noise will come into this. For now, we are considering there is no noise. Only input is coming to the measurement, coming to the measurement system. Noise in detail we will consider. There are many types of noise. How we can avoid it, we will consider it. Okay, is that fine, Utkarsh? Okay, next move to the next part. Threshold and resolution. So what is the meaning of threshold and resolution? So suppose you have an instrument, you have an input, and the input changes very slightly. It does not mean that you will get the output change. Now you keep on changing the input slowly, slowly, slowly. At some point of time, you will visualize that output change happen. So that minimum value of the input change for which you will see the output change happen is called the threshold. Okay. So again, I am telling, if the instrument input increase very gradually or slowly from 0, there will be some minimum value below which no output change can be detected. That minimum value is called the threshold. This minimum value is called the threshold of the instrument. Okay. Manufacturers generally specify this threshold as an absolute value or percentage of full scale reading. By two ways they generally specify. Then what is resolution? Resolution means smallest possible increment which can be measured by an instrument. So again, I am saying that suppose one instrument can measure a change in pressure of say, or you see that one instrument can measure that up to point resolution up to 0.1 volt, or one instrument can measure up to resolution up to 0.001 volt. Okay, so this is called the resolution. So suppose if you use an instrument which shows that 12.23 volt and it can give accurate measurement up to second decimal place. One instrument can give the accurate measurement up to first decimal place. That means which is giving accurate measurement up to second decimal place, that is more resolution. That has the more resolution. So the resolution is defined as the smallest possible increment value measured incremental between measured values. So as the term is used, the higher resolution means that smaller incremental change can be measured. So if I say that suppose we have two instruments, one resolution is high, another resolution is low. So which one you will prefer? Always you will prefer the resolution high because it can go highway. And if I say that one instrument has low threshold and another instrument has the high threshold, which one you will prefer? Low threshold value you will prefer because small change can be detected. Okay. So these are the difference between threshold and resolution. So let me see if there is any other query. Okay, there is nothing in the chat box. Okay. Another thing related to the sensitivity, what Utkarsh was discussing. One more thing I want to add, that there are, I said that few disadvantage of the sensitivity. Maybe another disadvantage could be the settling time. If your scale is too long and then say marker needs to go travel so long, so it response time may be little bit slow. That means you need to wait for longer time so that output reaches the steady state. That may happen also. Okay. Now let's come to the resolution and sensitivity. Now you tell me that for the resolution and sensitivity, do you understand? It is very simple. It is threshold and resolution. It is very simple. Threshold means the minimum input which can be detected minimum change in input which can be detected, and resolution means the smallest possible incremental values. So these two are similar but not exactly same. So the threshold means you have to change the values gradually from 0, and then you will detect at the point your output will move or your output will move. Then that is called the threshold. And the resolution means for the same smallest possible increment value you can measure in the output. Okay, so that is the resolution. High resolution is good. For example, here it is the last point. There is an instrument with a 5-digit display, say 0.0000 to 0.99999. Is said to have more resolution than an identical instrument which has a 3-digit display, 0.00 to 9.99. Both, you see, both can measure up to 0 to 10 degree, 0 to 10. But here also it is 0 to 10. So if I said what is its range, you will say 0 to 10. But what is its resolution? Resolution of the earlier instrument is more because it can go for the more decimal place, although the range is same. Okay. So first you see the range, then you need to see the resolution. Which resolution is, if you get the in the same price, you will get the more resolution that is preferable, acceptable. You will choose that instrument. Is that fine to all of you? Yeah. Okay, fine, very good. Omkar Vivek said that resolution and threshold is clear. Very good. If you write this little bit that okay, it is clear, it is not clear. So I feel that I am interacting with you, and I feel good to speak about it more and more. That is the only thing, nothing else. Otherwise, it's see in the complete empty room, only one laptop. I am speaking. Sometimes I feel okay, what I am doing. Anyway, so Modhur, I'll send these slides up to page 50 or something. There is no issue to all of you. I'll send. Okay, but you keep on reading the Doeblin books and keep on solve the examples as well as the exercise. That is also very important from Doeblin book. In internet, you may see that the solution manual is available if you search more, and that can be helpful to solve the numericals in Doeblin books. But we'll follow and we'll solve the numerical in Doeblin books, as well as we'll take the solved example also. Doeblin is the main book which we are now following. Okay. Fine. So if you have any query, you can say. Otherwise, today now we can end here, and next class will go on Monday, and maybe next week we'll try to take 2 classes more, and so on. We'll move. Okay. Okay. So if you have any query, you can ask. If any comment, you can give. Or resolution, Aman said that is resolution the same as the list count? Yeah, it's kind of, yes, list count for any instrument. That is a kind of, you are correct. So and if you suppose you don't ask the same class, you can note it, you can ask on the next class. I'll try to answer, and try to make it more interactive so that we feel, although we are not in class, but we feel that we are in class, and it will be good to have such discussion and such interactive classes, and it will be good for you and me. Okay. So thank you all of you for attending. Attendance is still low. You ask all of your friends, because now I am assigning some marks on attendance so that they come and attend the class, so that they can learn, and finally it will be helpful to them. Okay. Thank you all of you. So let's stop here. Thank you for attending the class.